Do you truly believe that everyone can actually achieve the functional use of English language from just spending 5 minutes a day playing games online? To be fair, I guess it depends on the target language and a learner's native language. Needless to say, French speakers learn Spanish much easier than Arabic speakers. As a native Korean language speaker myself, I learned Japanese easier than English speakers. As I mentioned in the previous video, the greater the causes of obscurity that exist between a learner's native language and English. Educators need to provide more suitable instruction to meet the unique needs of learners. Language teaching mobile apps or websites often boast about offering lessons with more than 100 different languages. Fixated on the target language only approach, learners around the world are pigeonholed into this oversimplistic method of language learning. All learners are simply labeled under the unilateral target language categories that these companies provide. According to Google search, there are 6,909 spoken languages in the world. Only 230 are spoken in Europe, while 2,197 are spoken in Asia. In relation to the structure of English language and its basic ground rules, what's actually calling the shots is the sources of obscurity, namely the varied, non-existent, and undifferentiated concepts from the rest of the 6,908 learners' native languages around the world. However, learners around the world are lumped together as undifferentiated, including Asian learners who make up 1/3 of the world's populations. This oversimplistic and one-sided approach has been accepted as a norm without the acute awareness of the so-called inhibiting effects of a learner's native language. It's the one-size-fits-all approach that has made educators ineffective for too long, unable to identify the sources of linguistic ambiguity and complexity that led their learners astray. The whole point of machine learning is to avoid thinking at such a coarse level and human limitations. Educators, scientists, and learners around the world neglect the distinct challenges that are resulted from the varied non-existent concepts due to learners' native languages in relating to English. The success of second language education hinges on providing a well-suited solution through developing a clear awareness of the non-existent concepts within a learner's native language in relating to the most basic English rules. First, let me make it clear that machine learning is not a replacement for in-person lectures on the web. Machine learning is learning about learners and extracting the deep regularities from the right kind of data. YouTube has a learning algorithm to figure out your tastes and recommend video clips. According to the author of Master Algorithm book, the goal of machine learning is to find the best possible learning algorithm. Whoever learns fastest and has the best algorithms, the best possible models wins. What's at stake is seeking the solution, the best models or learning algorithms that create the awareness and meet the unique needs of a vast amount of learners and advance their functional use of English language in the most time, energy, and cost-saving way. It's the educator's duty to lay the foundation that resolves the phonetic, grammatical, and semantic obscurities for learners around the world. I developed a patented machine learning program called English Axiom. Taking into account 2 generations of empirical study and fieldwork on diverse Asian learners, I invented simple learning algorithms of the basic English rules with a machine learning approach. My learning algorithm design is based on a schematization of the basic English rules of its phonology, grammar, and word arrangements. It clearly defines the crucial components of the English language that have remained unidentified by educators and learners. My learning algorithm design is the missing piece of the language learning process, encapsulated as a practical and concrete model. One of the learning algorithm designs that I invented is the breakthrough sentence converting algorithm that enables learners to create one English sentence into a minimum of 118 sentences. Let me briefly explain my sentence converting algorithms. Compared to the 16 different English tenses, the Korean language can fully operate with only about 9 tenses due to a much broader tense usage. This algorithm design is only centered on the 4 basic English tenses. Simple past, I did. Past progressive, I was doing. Simple present, I do. And present progressive tense, I'm doing. It is intended to make a clear distinction between simple present and present progressive tense that is undifferentiated in Korean. The English linking verbs am, are, and is are replaced with one single verb, and there's no concept of a third singular form, such as does, in the present simple tense. A set of 19 designated English sentences provides the essential grammatical framework. And this sentence converting algorithm is also structured around the 4 elements of English sentences. Number 1, 7 different subjective pronouns. Number 2, verbs. Number 3, 4 tenses. And number 4, 4 types of sentences. As mentioned in another video, with a clear understanding of the distinction between a present and past participle, boring and bored, a learner can make a minimum of 56 different sentences by applying the 4 elements: subjective pronouns, types of verbs, tenses, and types of sentences to the linking verb algorithm. For instance, the second sentence, I'm tired, from the 19 designated sentences. I included about 50 different adjectives and 5 different adverbs in the algorithm. This sentence, why aren't they quite satisfied with the results, is considered to be the same sentences as Tom is bored and Tom is boring and I'm tired in the frame of the 19 designated sentences. Using the action verb algorithm, learners instantly create one English sentence into a minimum of 118 sentences and a minimum of 17,000 more sentences by replacing 144 different action verbs. It ensures learners to acquire the concept of undifferentiated tenses and their meanings. With acute awareness of the obscurities, learners attain creativity by connecting the forms and their meanings between the 2 fundamentally different structures of languages. These sentence converting algorithms were a major breakthrough, especially amongst a group of Korean elementary school students whose English communicative skills surpassed average college students, not only in my fieldwork, but also during an oral proficiency interview test, OPIC, developed by American Council on the Teaching of Foreign Languages. My learning algorithm design is the missing piece of the language learning process. It develops acute awareness of the non-existent concepts within a learner's native language. It lays the essential groundwork and establishes clear standards for both learners and educators around the world. It is the standard metric system in language that connects the essential English ground rules with a learner's native language. This missing piece provides the essential guiding principle by comparing the basic structures of English to a learner's native language. By acknowledging the crucial role of a learner's native language, learners can truly connect the most essential concepts and their meanings between the two different languages. Both educators and learners must distinguish the sources of obscurity in order to achieve the durable grasp of core concepts and reach the meaningful level of language. In relating to the structures that define the English language, learners are able to systematically attain creativity and achieve basic English communicative skills. My learning algorithm design provides an example of how to resolve the causes of intricacy and obscurity during the second language learning process using Korean language learners' experiences. They have already given new insight into individual Korean learners' levels of understanding and their performance, as well as statistical regularities in data extracted from Korean learners as a group. It offers an archetype model, and they're intended to be applied to a wide range of learners around the world. This learning algorithm design provides the best model that uniquely creates awareness and clearly identifies the varied non-existent concepts of languages around the entire world. It enables learners to overcome their distinct challenges with its scientific solutions. Sharing the data of varied obscurities drawn from learners on a global scale will spark new directions in research and development and transform the process of second language acquisition down the line. It is my dream that my learning algorithms galvanize educators, scientists, non-native workforce, and learners around the world to take prompt action and adjust their approach to the second language education.